Lesson 19 is all about factors and prime numbers. And our first key vocabulary word that we have is actually a phrase, and it's factors of a number. And what we're going to write down today for this factors of a number definition is whole numbers that multiply together to equal a certain number. Again, that's whole numbers that multiply together to equal a certain number. So let's go ahead and say we want to find factors of, let's say, 9. If we want to find factors of 9, well, in order to get 9, 9 is equal to 1 times 9. So we could say 1 is a factor of 9, and 9 is a factor of 9. We could also say 3 times 3. So 3 is also a factor of 9. The numbers that multiply together, that can get us to 9, are factors of 9. Let's look at another one. Let's say we have 15. If we have 15, 15 is going to be equal to, well, 1 times 15. So 1 is a factor of 15. 15 is a factor of 15. We could also have 3 times 5. 3 is a factor of 15, and 5 is also a factor of 15. So all 4 of these would be our answers. We'll look at one more right now. Let's say we had 13. The only whole numbers that we can multiply together to get to 13 are 1 and 13. So the factors of 13 would only be 1 and 13. Let's move on to our next slide. What are the factors of 10? So if we look at 10, well, in order to get 10, 10 is equal to 1 times 10. Now, the number itself will always be a factor of that number, and so will 1, because you can always multiply 1 times the number to get back to the number. That's the identity property of multiplication. To get 10, we could also say 2 times 5. So our answers, what are the factors of 10? Our answers would be 1, 2, 5, and 10. And when we report our answers, it's nice to put them in numerical order so they're easy to read. Okay? And we've got our whole complete answer here. These are all of our factors of 10. Next problem says, how many different whole numbers are factors of 12? Well, let's go ahead and see. 12. 12 is equal to 1 times 12. It's also equal to 2 times 6. We know we're going to be able to multiply 2 times something to get to 12 because 12 is even. And it's also equal to 3 times 4. And those are all of our whole numbers that are factors of 12. Well, we have 1, 2, 3, 4, 5, and 6 different whole numbers that are factors of 12. So our answer, this time, is 6. And we're all done. Let's move on to our next slide. Okay, we've got some more key vocabulary today. We've got something called a prime number, and you might have heard of a prime number before. You might, in fact, already know what it is. A prime number is a number that has exactly 2 factors. So if we looked at that number 7 again, 7 was equal to, well, only 1 times 7. It has exactly 2 factors. How about 13? 13, we saw that one. That was 1 times 13. So, well, there's only 2 factors. So that number, 13, is prime. The number 7 is prime. Let's look at this one. Let's say we had the number 12. We know 12 is equal to 1 times 12. We know it's equal to 2 times 6. And we know it's equal to 3 times 4. There's more than 2 factors there. There's 6 factors. So 12 is not prime, P-R-I-M-E. I was starting to make a capital R there. You could probably see that. Make sure you've got this copied down into your notes. We're going to move on to our next slide. All right. The first 4 prime numbers are 2, 3, 5, and 7. What are the next 4 prime numbers? People often ask, why is 1 not a prime number? Well, 1 is equal to 1 times 1. Well, there's only one factor there because these two are both the same numbers. So remember the definition of what a prime number was? Exactly 2 different factors? Well, 1 is not prime because it only has one unique or different factor. So the first 4 prime numbers are 2, 3, 5, and 7. What are the next 4 prime numbers? When you come into Mr. Wilkinson's classroom, see if you can find the prime number chart. If you don't have one at your house, this is a way that you can solve this problem. We've got 2, 3, 4, and what we're going to do is just make a list. And we're going to make a list, and we're going to make it out to 15 right now. And we're going to circle all the prime numbers as we go. Now we know 2 is prime, we know 3 is prime, and we know 5 is prime, and we know 7 is prime. 4 is not prime because we could say 1 times 4 or 2 times 2. 6 is not prime because we could say 1 times 6 or 3 times 2. 8's even. It can't be prime, so we're going to cross it off. We'll cross off the 4 and the 6 as well. 9, well, we saw 9 has 3 factors because 3 times 3 is also 9. 10 is even, can't be. 11, the only way we can get to 11 is 1 times 11. So 11 will be our first answer that we have for this question. That's the first of the next 4 prime numbers. Then we'll go ahead and we'll look at 12, can't be. We know 14 also can't be, and we know 15 can't be because 15, remember, also had 5 and 3 as factors. So 13, we've worked with that one. 1 and 13 are the only factors of 13. Well, we've only got the next 2 prime numbers after 2, 3, 5, and 7. We need to continue our list. 16, 17, we'll move down to our next row, 18, 19, and we'll go to 20. Let's check this out. So 16 is even. We could say 8 times 2 or 4 times 4 and 1 times 16 to get to 16. 17. Oh, the only way to get to 17 is 1 times 17. So 17 is prime. Then if we look at 18, well, 18 can't be prime because it could also be 9 times 2 or 6 times 3. Then 19. That is 1 times 19. We've got our last prime number. We can stop now because we need to find out what the next 4 prime numbers are. We've got 1, 2, 3, and 4. So our answers are 11, 13, 17, and 19. And we're all done with this problem. We're going to move on to the next slide. Pause now if you need more time. Our lesson practice, we will continue working with these concepts on page 97. Make sure you've got your notes completed, and I'll see you next time.